Welcome to the webinar, CLT for the Sustainable Wooden Future. I'm Thomas McGinley and your host. Today's topic revolves around construction of the future in renewable materials. Year after year, CLT, or cross-laminated timber, continues to gain popularity due to its unique design, production, and construction benefits and low environmental impact. This webinar aims to give you a sneak peek into the innovative and sustainable wooden future through industry specialists. We will show you pre-recorded videos from our panelists and then host a live discussion at the end, answering questions from the audience. Our first speaker is Janne Piilajaniemi. Excuse my Finnish, it's still in progress. Professor of Architecture at the University of Oulu, and he will talk about the simplicity of massive wood architecture. Next, we have Matias Rantala, Managing Director at Pinomatic. He will discuss the CLT plant case. After that, we have Sami Melinainen, Sales Director at Pinomatic, and he will talk about the most important points of the CLT production line. And finally, Christopher Mills, Head of Innovation at Kiilto, and he will discuss why we use adhesives in CLT production. Now, let me introduce the co-organizers of today's event, Kiilto and Pinomatic. Both are family-owned companies and both share Nordic roots. Pinomatic has been in business for over 30 years. As an industrial equipment supplier in the wood processing industry, they design, manufacture, and market production lines and equipment devices on a turnkey basis and deliver solutions for glulam and CLT production, non-settling log production, LVL and plywood production, and more. And in recent years, they have delivered solutions to France and even Chile and Russia. On the other hand, Kiilto has existed for over 100 years and operates in 11 countries. They develop industrial adhesives for structural bonding, paper and wood making, woodworking, and fireproofing. Guided by environmental responsibility, Kiilto has a range of renewable and biodegradable properties in their adhesives that originate from side streams in the forest industry. Now, before we begin, let's explore this platform. At the top, we have polls, which we've asked 5 questions from the audience. So hopefully you have some time to answer these either now, during our presentations, or at the end, and we can review them together. We also have a program where you can see our timeline and agenda, so if you have to step away momentarily for a coffee, break, etc., as well as our performers and a quick bio about the people involved. At the right, we have our chat box, and you can either leave a message, a question, with your name or without your name. And as you can see, there's a gear icon at the bottom that offers the 2 options. So please engage with us today. We're looking forward to meeting with you. And at the left, you have our webinar icon that notifies us that we'll save it for the next 30 days for your reference, and you can share with family and friends if that suits you. And then finally, there's a little bit more about the event organizers in that tab. As you can see, a quick introduction video and a quick little bio. So it was cool to see that we have over 100 people that registered for the event today from all over the world. So maybe if you could help me out to jumpstart the conversation, where are you virtually attending from today? And for me, it would be Finland. And then finally, I also noticed that there's a mix between professionals and students. It's interesting where the students might have come across for this webinar was a Professor Janne that required his love and supports. So thanks for taking it this far, and let's start with the first video. Janne, about the simplicity of massive wood architecture.
Finland is a land of many forests. Even today, we still have about 75% of our land area covered with woods. That's why we have still kind of like a forest human attitude also on what comes to the building and architecture. If we look at the old traditional wooden houses, for example, in the countryside, we still have examples from the houses that are several hundred years of old. And they are still in use and still serve as human settlements in Finland. Wood has been the primary material in these, of course, and especially massive wood. Even after the Second World War, when Finland was rebuilt, the wood was still the main material which was used in these carpentry houses. And that is perhaps the reason why we still, quite many Finns, choose wood as a material for our housing, even nowadays. If we look at the old public buildings, we still have examples of several hundred years of old churches, for example, that are made out of massive wood. And they are still in use and still in good shape. Wood is a very long-lasting material, especially when it's used as a massive element in houses. If we then look at the more contemporary architecture, for example, Alvar Aalto used wood in many of his famous works. Like, for example, here in the Viipuri Library ceiling, there's this kind of curved ceiling made out of wood, which gives the building its kind of atmosphere. Or if we look at the most recent examples of Finnish architecture, like for example Oodi Library in Helsinki, the most characteristic feature in it is the curved big wooden facade. In the wood building, everything begins when we cut down the wood. It's a kind of act that we have to be careful with, because that is the point where the life of that wood ends as a piece of nature and begins as a cultivated timber object in our houses. We have learned ways how to utilize the wood. We can saw it, make it different kind of pieces, and then collect it again to serve our needs. Quite many of the houses nowadays are built out of layered structures, like for example balloon frame structure, which can still have a wooden facade. In these kind of layered structures, every layer has its own meaning. Like for example, the plastic or the paper inside keeps the moisture away from the structure. The insulation keeps the warm inside and cold outside. And then, for example, in the facades, wood can give the appearance for the building. But these kind of layered structures have proved to be quite vulnerable on what comes to, for example, moisture and repairing. Therefore, more and more recent innovations in house industry have become to look for solid materials, like for example out of wood. Also, there are efforts to make more thicker and more solid structures to utilize. Of course, if we look at the traditional ways how to use massive wood, the massive logs are the most traditional ones. But even those have been developed into lamella logs, which combine several pieces of wood and therefore make the behavior of the massive wood more controllable. There are even examples of the non-settling log structures nowadays. Then we have, of course, different kind of other massive wood elements. Like, for example, one of them is CLT, cross-laminated timber. And the idea, of course, with that is to make large massive wood elements which can be utilized in a building in a more contemporary way than, for example, traditional log building allows. There are also other kinds of massive wood products, such as glue laminated timber, lumber veneer laminated timber, and also other kinds of plywood materials. Quite many of these, actually all of the previously mentioned, use glue as a part of the structure. And that has proven to be very good on what comes to the controllability of the structure and the material. But if we look at the architecture nowadays and the opinion of architects, especially young architects, quite many of them think about environmental issues and would like to see some kind of alternatives to these kind of glue laminated structures. So far there are a few other kinds of massive wood products which do not use glue as a laminating structure, but are mechanically fastened timber products. For example, double laminated timber, DLT, or breadstable are examples of these. These have been produced and developed in Central Europe. But there are also some Finnish examples of the mechanically fastened timber products. But anyhow, glue laminated timber products such as CLT have proven to be very good on what comes to the controllability and buildability of these kind of wooden houses. But of course, it would be good to see what kind of development phases there could be in the components of these glues and what kind of efforts there are to make these more environmentally friendly. But if we look at the most popular massive wood structures such as CLT or lamella log, the principle in most of these are the same, similar. The finest thing, if we think about the architecture of these, is that we have one solid material basically, which we can see from inside and outside, and that forms the whole structure, the whole surface, and the whole insulating element for the buildings. In Finland, we have such a handicap in our legislation that we are allowed to use massive wood even in our walls without any insulation. And that is very exceptional also if we think about international legislation. But the idea is, of course, that if we use massive wood, we storage that much carbon that we can allow a little bit more use of energy to heat these houses. And we still are very environmentally friendly. The reason why people are fond of using massive wood in their houses is, of course, also the indoor air quality. And that has much to do with the fact that we can say that these kind of massive wood structures breathe. That doesn't mean that they breathe from inside to outside some kind of air or even gases, but the effect is created in such a way that the moisture which is inside in the indoor air goes a little bit inside the wooden surface, and then it's released again to the air. And this kind of effect gives us the feeling of the wall breathing and freshens the air as well. Then if we look at the CLT, what kind of pros it has in comparison, for example, to log building. CLT, we can produce very big elements out of it, and then therefore we can use it as a similar kind of material than, for example, concrete, prefabricated concrete elements. So we can make whole walls and slabs out of it and construct the whole building by using only wood as a material, as a load-bearing structure. One big advantage of using CLT, and especially these kind of prefabricated elements, is also that we can produce big space elements out of it, these kind of blocks, which include even several rooms, several pieces of houses, and then we can connect these together on a construction site in order to make this kind of, for example, big block of flats out of them. And especially this kind of building technique to use space elements is possible only by using wood. It's not possible by using concrete, for example, or using steel, because they are much more heavier materials, and it would be impossible to transport these kind of elements to the construction site. But we can do this by using wooden elements. If these are connected, for example, to building a facade on a construction site, end result can be very fascinating, like in this example, the Finlandia Prize Award winner from 2015, Puukuokka block of flats in Jyväskylä, designed by OPA architects. CLT can be used in a different ways in the buildings. Also, besides as a space elements, we can make load-bearing walls out of it. We can make other vertical structures. We can make beams, and we can make even other kinds of smaller objects to the building, like, for example, stairs and such furniture, etc. CLT also allows to use those kind of expressive elements or expressive qualities of wood, which are traditional, for example, in the Finnish architecture. This is an example of the very recent office building in Helsinki, Supercell office, which has a curved CLT elements as a very fundamental and visible piece of the lobby area architecture. But maybe the biggest advantage of using wood is that, especially for Finns, it is very familiar and natural material. Even as a small kids, we are learned to be close to wood, close to living woods, and close to wood which is used as a building material. The touch of the wood, the smell, the warmth of the surface are familiar to every one of us. And therefore, it is very essential to find ways how to develop this tradition and how to make even novel solutions out of wood, out of the wood materials and out of the wooden structures and architecture altogether. Thank you.
Okay, so we just heard from Professor Janne about how CLT offers a forced human approach to architecture and can draw upon different aesthetics and senses for both the builder and end user. Now we're going to come from design to production and head into the conversation with Matias and Sami from Pinomatic, where they'll discuss the CLT plant case, as well as the most important points in building a CLT production line.
Good day, my name is Matias Rantala, and I'm the Managing Director of Pinomatic Oy. First, I will introduce my company and then go through the case of CLT plant. Pinomatic is a family-owned company from Western Finland with a focus on delivering automated wood processing lines, mainly to Europe. Pinomatic employs 54 persons with approximately 10 million euro turnover. Pinomatic started as an automation company and later expanded in such a way that we have the complete delivery chain in our own factory, all the way from designing and fabricating machines to installing and startup at the customer site. We also test the machinery as well as we can in our factory, meaning that we build the line according to the layout and test the functions with customers' product. This way we can shorten the startup time after the installation. Pinomatic also provides customers with spare parts and maintenance services. Pinomatic provides customers with machinery for CLT, glue lamp production, plywood and LVL, sawing and handling, planing lines and finishing lines, just to name a few. You can also ask for help planning or designing your factory. Next, I will go through the case of CLT Plant, a Finnish company focusing on big CLT panels used in apartment buildings and public construction. The company, CLT Plant, invested a new factory in 2018, with Pinomatic designing and delivering the mechanization of the line. The line can produce CLT panels up to 60 meters by 3.5 meters with thickness up to 40 centimeters. All panels are machined according to the order. The factory can produce up to 50,000 cubic meters of CLT panels per year, and the machinery in this configuration requires about 4,000 square meters of space. The main points in the line are infeed planer, friction press, vacuum stacking and panel handling, CLT press, and board milling. Finger-jointed boards are fed to the line with a vacuum destacker. The destacker feeds the line from 2 stacks according to the recipe, the long lamellas or the shorter crosswise lamellas. The long lamellas are fed through the planer and glue is applied at this point to the side of the lamella. The planed lamella are temporarily stored to a 2-story conveyor for a short buffer. The lengthwise lamellas are then lifted to the CLT press infeed with a vacuum lifter. The crosswise layer is handled a bit differently in this case. The infeed destacker feeds the boards from another stack, and those boards are then cut to the width of the CLT panel. The layer is then glued and pressed with a friction press before the CLT panel is assembled. When the crosswise layer is pressed in such a way, the finish of the layer is gapless and very smooth. It does not require much processing if placed on a visible side of the CLT panel. Now the CLT panel is assembled and glue is applied in front of the CLT press. After the pressing cycle, about 25 minutes later, the complete CLT panel can be lifted to the milling station or to the storage space or a wagon. The vacuum lifter is a versatile tool in this type of layout. The panels can be stacked as a small buffer and lifted back to the milling line in a way that is not tied to the order that they were pressed. The production line can be run with minimum of 4 persons, and the investment for such machinery is around 5 to 6 million euros. And now Sami will go into deeper details and options for similar systems.
Hello, my name is Sami Malinen. I'm working as Sales Director in Pinomatic. There are a few points that should be considered before starting CLT production planning. The first thing is to have a capacity where we are aiming at. For example, if we have a CLT panel 16 times 3.5 meter with 5 layer and lamella thickness 34 millimeter with 30-minute pressing time, we have output of 25,000 cubic meter a year in one shift. With same lamella thickness, 12 meter long panel and 50-minute pressing time, we have output of 10,000 cubic meter per year in one shift. What is the maximum size of panel? What is planned to be produced? CLT panel 16 meters, 12 meters, or maybe only 6 meters. Chosen size will affect a lot of space needed for line, how thick panel are and how many layers in one panel. What kind of raw material is planned to use, meaning thickness, length, width, and wood species. Is finger jointing also on line, or is it in a separate line, or are you buying ready finger jointing lamellas? If strength graded material is needed, is the strength grading done online or buying ready strength graded lamellas? Is it from decorative aspect, need to have top layer of panel some special wood species or shapes. For example, thermowood, exotic wood species. There are a lot of different kind of possible features you can have in a CLT production line. It is also possible to start with one configuration and later add new features if the demand of the market will change. Are you building the line to new facilities or are you using some existing facilities? There are a lot of different layout options depending on the space. Most important thing in layout is that material flow is rational and enough buffer in right phase of process. Here we can see some example of layouts. Higher capacity line panel size 16 meter, including finger jointing, CNC machining, and sanding, takes space in this example 13,000 square meter. In smaller line with 12 meter panel, including finger jointing, needs space in this example 4,000 square meter. Edge gluing of lamellas. At first, the lamellas are cut to exact length. With accurate cutting, we can minimize the material waste. The lamellas are fed one by one to edge glue press. Glue is accurate dosed to the edge of lamellas. Features of glue is key to get this process done properly. When we have glued 2 to 3 lamellas, they are pushed to the edge glue press. Friction of edge glue press makes sure lamellas will stay side by side without any gaps. When lamellas come out of the press, glue is dry enough and we will have full-size edge glued lamella panels. Edge glue press works continuously. What about the benefits we can achieve with edge gluing? We will get nice surface without gaps between lamellas. This is a big benefit when we are using panels in visible use. Some markets and some customers also demand edge gluing of lamellas. Handling and storing of the edge glue panels is much easier. CLT press is simpler when lamellas are already edge glued. Vacuum stacking in buffer handling. In feed of the line, we have several stacking places for different dimensions or qualities in a rather small space. In this solution, we can see that there are 3 different stack places we can feed the layers to infeed on production line. Vacuum handling of lamella is smooth and gives a lot of flexibility in layout designing. It also allows different driving modes for different kind of products. In this solution, there is 3-level conveyor. Same vacuum stacker takes care of 2 top levels and then also edge-glued cross-lamella panels. Automation is the key word to high productivity of line. Automation needs to be involved from day one when the layout of the line is designed. Detectors and sensors for machines are designed together with mechanical designing. Functionality of the line is made together with machines and smart automation. Smart automation makes the line safe and easy to use for operators. Safety areas are designed so that if one function is in error, it just stops that area and the rest of the line can still run. Here we can see several different safety areas in one line and with different colors inform the operator the status of each area. When operator have fixed the problem, line starts to run automatic again. There is a fast change of settings with new dimensions and only few places where need to do manual adjustment. And it can also be fully automated. With fully automated adjustment, we will avoid mistakes of operators. Interface is equipped with 3D images, so it is easy for operators. Here we can see how the settings are changed in one solution. In error situation, smart controlling system will propose possible failure of the system. It is possible to make recipe system operators update with new products. Here operator is doing a new product to recipe system and then saving it to controlling system. High automation level will also mean that there are not any monotonous hard work for operators. Operator will just monitor the production and make sure everything runs smoothly. Lack of fixed working place for operator means there are only few operators need to monitor the whole line. Buffer controlling system means online information of production. It is possible to add IPC, integrated production line control, and then it is even possible to get production information from upper level controlling system. This means that the production will be optimized and best productivity of raw material and production line will be gained. The controlling system is fully monitorable and editable by remotely connection. To wrap all this up, there are a lot of things that need to be considered when a CLT line is planned to build. All solutions need to be well balanced together and clear view where to aim and to be aware what kind of demands the future can bring and how to respond to those demands.
Thanks, Matias and Sami. Just a friendly reminder, if you guys could just head to the polls, I'd now see that we have over 140 participants, but only about 10 votes or so. I know it's after lunch, but hopefully you can make some time to visit that again. As for the last topic of the day, we will now discuss bond, Kiilto bond, the glue that keeps it all together. And Christopher Mills, head of innovation at Kiilto, will talk about why we use adhesives in CLT production.
Hi, I'm Christopher Mills, and I'm glad to tell you a bit about CLT adhesives. I've been working for Kiilto for about 10 years, and all of that time I've been working on wood adhesives. And actually CLT is a very interesting product because during that time it's grown hugely. And in fact, next year the predicted capacity increase is double what it is now, so it's really in a huge growth phase. So CLT, cross-laminated timber, is a product made with adhesives, and that's what I want to talk to you about today. So why do we use adhesives to make CLT? Well, first of all, there are a couple of technical factors that we use. The fact that adhesives are very light compared to nails and screws and other ways of fastening. You only need actually 100 to 150 grams of adhesive to bond a square meter of wood together. So that creates, with 5 kilos, you can bond a whole CLT panel. And that's quite a good benefit. Another benefit is the strength. So adhesives are very strong. In fact, with this small piece of CLT I have in my hands, I could lift a car or even a truck into the air. Another good factor about adhesives is that they create even stresses. So since the adhesive is a layer between the wood, then there's no point that's holding the wood together like you might get with a screw or other type of fastener. Then the adhesive I'm going to talk more about today, polyurethane adhesives, then they're actually quite flexible adhesives. So they're super strong, but at the same time they're super flexible. And that's important when we have a large surface area of a wooden product, that we don't get too much cracking and splitting. And the last but not least factor is that if we nail together CLT, then of course, everyone understands that when we start to CNC or cut it into shape, then we have to avoid all the screws and nails and so on. But when it's bonded together, we can just cut it with any normal woodworking tool. And if we go back to bonding wood, then wood is a very interesting material because whenever it gets moisture, then it expands, and when it dries, it contracts. And that's one of the main points for bonding wood successfully, is how can the adhesive act in the situation where the wood is expanding and contracting. And there are basically two options. So when we look at it, we can make an adhesive that's very stiff and that moves the stresses from one wood part to another into the wood and sort of stabilizes the wood around the bond line. And that's a good option. But then when we go to a product like CLT, where the stresses are actually quite high because it's cross-laminated, which means that the wood is bonded at a 90-degree angle, then you start to get more cracking with this type of adhesive. So actually, we believe the best type of adhesive for bonding CLT is one that's flexible, like polyurethane. And what that means in practice is that when the wood is expanding and contracting due to moisture, then the adhesive layer also expands and contracts. So I've been talking about polyurethane already, but maybe some of you aren't quite sure how you make polyurethane. So basically we have two main components, a polyol, which is a polymer which has some alcohol groups. So that doesn't mean that there's actual alcohol as we're used to drinking in beer, but that there's OH groups in the polymer chain. And then we need isocyanate, which is the sort of reactive motor of polyurethane. And in addition, to make a polyurethane product for bonding CLT, then we need catalysts and also some rheological agents to help apply the adhesive and to use it in factory conditions. And basically, we always talk about polyurethane as a one-component adhesive, and it is a one-component. So what we deliver to you is a one-component product, but it actually needs a second component. So it actually uses the moisture from the wood and the moisture from the air to react and form a durable bond line. And how that happens is that as soon as the adhesive is spread on the wood, then it starts to take moisture from its surroundings and reactions start to happen where polymer chains are joined together into larger polymer chains. And that's what we talk about when we say that the adhesive is curing. So basically the molar mass or the length of the chains of adhesive are growing rapidly. Now I want to focus a bit more on the factory conditions, because the adhesive is one thing, but of course where it's used. So the CLT production factory is a very important component. So one benefit of having a one-component product is that we can deliver it quite easily to the factory and in large amounts. So a typical CLT factory being built at the moment is rated for a capacity of 60,000 cubic meters per year. And that equalizes a lot of sacks of glue. So that's important that we have a one-component product and it's easy to order and store in the factory. The benefit of polyurethane is that it's also a 100% solid content product. So there's no solvents or no water. And that actually helps during the transport phase. It means that we're actually delivering less kilos of adhesive to produce a good bond. But the main reason that polyurethane is so popular for CLT factories is that it needs actually only a cold press. So quite a lot of production processes use heat or high frequency to achieve good bonding times. But polyurethane, since it reacts to the moisture in the wood and in the air, then you only need the mechanical press. You don't need a heated press. And that's a big factor when designing a factory. Also, polyurethane tends to foam. So a side product from the reaction with water is carbon dioxide, which is causing the polyurethane to foam. And foaming is actually a good thing for an adhesive when it's needed that the adhesive spreads evenly across the surface. In some cases, excessive foaming can be a bad thing. So it's good to look at the foaming behavior of the adhesive you choose, because if you have to sand the surface or otherwise you want a nice clean surface after the press, then you don't want too much foaming of the adhesive through the bond lines. And I'm not sure if you can see in the picture, but polyurethane makes an invisible bond line. So it's very difficult to see the bond lines in the wood. And that creates the nice clean surfaces that we really like with CLT. But can we use just any polyurethane for bonding CLT? Actually, no. So standards are very important for making safe construction elements. And since CLT is a construction material, then we actually need to quite vigorously test adhesives that are used for structural bonding of wood. And there are some product standards like the EN 14080 for glulam, EN 15497 for finger jointing, and EN 16351 for CLT that determine what testing the adhesives need to go through before they can be used to produce the structural layers in CLT. And for polyurethane, then all these tests that the adhesive needs to go through they've been collected into EN 15425, which is basically the sort of guidebook for testing an adhesive for use in structural wood, which is based on one component polyurethane. And EN 15425 has 12 different compulsory tests, and actually the testing is very vigorous. So the shorter tests take about 2 weeks to perform, but the longer tests take about 13 months to perform. So the adhesive that's in the CLT product is actually tested for a very long time to make sure that it's stable against thermal stress, moisture stress, and also is physically strong enough to be a part of a building structure. And in some new developments in standards, then nowadays you can also have the adhesive tested for different wood species, so not just spruce and pine. And then also the use of a primer is now coming into the standards. So in some cases, if you have a very difficult wood surface, then you need a primer to bond it well. And another piece of testing that's not to do with the mechanical performance of the adhesive, but the safety of the adhesive, then of course there's a lot of formaldehyde regulation around the world. So there's tight restrictions in Japan, there's tight restrictions in California, in Europe, especially in Germany, and also in the Nordic countries we have a system called M1 to make sure that the adhesives are safe and aren't polluting the indoor air. But let's go back to the production and the factory conditions. So what are actually the key factors for the adhesive in CLT production? Well, of course, the wood is important. So looking from an adhesive perspective, what we look at in the wood is what's the moisture content? Are the dimensions exact? Because that affects the pressing pressure. And what's the surface quality? So if the wood has been planed many days ago, then it's a different surface to bond than a surface which is just planed a few minutes ago. So those are important things to look at in the raw material, in the wood. Then looking at the factory, then the factory, it's its own climate. So we all know with wooden products, then quite often the moisture and the temperature in the factory is controlled. And that's very important for the adhesive. And in fact, in some conditions, then the adhesive would need slightly different conditions to cure properly than are possible in a large factory space. And then we can think about whether we need to actually make local conditions around the press or around the adhesive spreading station, or whether we can change the conditions in the whole factory to make sure the bonding is successful. Then looking at the adhesive more in detail, then of course the application of the adhesive, how much is being applied, where it's being applied, are very important factors. And nowadays, with such developed production technologies, then it's actually a lot more demanding for the adhesive application, because you want just the right amount of adhesive in just the right place to get the proper or the best end result. And looking at the adhesive, then what kind of factors are really important in the adhesive? Well, one is the open time, which means the time that you have to lay up your CLT panel. And then the other important factor, of course, is the pressing time. So these two factors basically determine the production maximum capacity of a factory. So they're really important factors to look at in detail for every bonding station before planning a factory. And when we're talking about the pressing time and the open time, then a simple way of looking at it is to think of the ratio. So how long is my open time compared to my pressing time? If we look at the factory conditions, then what's important there is that we have enough grams of water in the air to provide the moisture for the adhesive to react. And that's a key point that I talk to a lot of customers in Northern Europe, especially with winters being as harsh as they are, that it's not the same thing to have a relative humidity of 50% if the temperature is 18 degrees as it is to have a relative humidity of 50% when the temperature is 30 degrees. So we have to look at the absolute value of water in the air. And actually, air can hold more water, or relative humidity means that how much of the capacity that the air can hold are you using, and that capacity changes as the temperature increases. So in cold conditions, it sometimes can be quite impossible to get enough water from the air to make the adhesive react normally. So that's a very important point, especially for northern conditions. And some practical ways that that can be tackled is that we can look at whether opening the doors of the factory are causing locally dry conditions, and then make air barriers or other solutions to prevent the moist air inside the factory from escaping. Now, if we go into the actual production process, then what I mentioned about pressing time and open time, then it turned into actual calculations for how many CLT panels you can produce in an hour, in a shift, in a day, in a week, in a year. And looking at the production processes which are popular now and probably for the next few years, then bonding CLT into panels, which are then bonded together to form the CLT structure, is actually one of the fastest ways to produce a lot of CLT panels in a short time. And it's also much simpler from the press mechanics. And if we need to bond the CLT into panels first, or the timber into panels that form the CLT, then we need a super fast adhesive, because we don't have many tens of minutes to wait for each panel to be produced, because even in one large CLT panel, there can be 9 layers. So looking at one of our adhesives for bonding into panels, then we can see that we've optimized it to be around 100 to 150 seconds that's needed to form the panel. And that turns into an output of 36 to 41 CLT layers per hour, and that can be the bottleneck in your production. Sometimes it can be the main press, but sometimes it can be the press that's forming the panels. So please look at every point in the factory where you're bonding and think about it from a bottleneck perspective. What kind of adhesive and how fast it needs to be that I can get the full production output that I'm planning from my line. Okay, so now we have a produced CLT panel and we're going to the customers, and one of the questions that crops up is, okay, so we now have a bonded wooden structure. Is the adhesive preventing moisture from moving inside that structure? So that's a common concern, and one that has been thankfully studied. So there was actually a very interesting research paper from Austria in 2010, where they used a neutron beam detector to follow the movement of water through the wooden structure with bond lines. And what they noticed was that, yes, different adhesives slow down the transport of moisture in different ways, but none of the adhesives actually stop the moisture from going through the bond line totally. And looking at the different results, then we can see that the number of bond lines is important to how quickly the moisture can go from one end of the wooden structure to another end of the wooden structure. And actually there have been some approximations made that a bond line is equivalent to between 12 and 26 millimeters of spruce wood. So in essence, you can think of a bonded wooden structure as just a thicker piece of wood as far as moisture is concerned. And in normal conditions with dried wood and protection from weather, then usually the moisture is only affecting the outer layer of the wood, and then it's getting more moist and drying the outer layer without actually moving through the whole structure. But in conditions where you're, for example, using CLT as a floor structure and then putting screed on top of the floor and the screed needs to dry, then you have a long time of higher moisture content on top of the CLT panel, and there it's important that the moisture is also able to get through the CLT panel and for the whole building to dry that way. I wanted to talk also about sustainability and looking a bit ahead. So, of course, the main point in a structural product is that it's safe. But what does safe mean? For us as a chemical company, safe can mean that the chemicals are safe that we use in the adhesive. Safe can also mean that the product fulfills the requirements mechanically, or it can mean that the product is safe in case of a fire. And nowadays, when we're talking about sustainability, then we not only need safe products, we need safe products for the environment. And in that way, the life cycle analysis of the products is becoming a factor now in this decade. And this whole sort of looking at the adhesive from many different angles is actually quite a large challenge for standards and regulations, because they are generally quite slow to develop. So then if you have environmental concerns on one hand, but safety concerns on the other hand, then it can be quite a slow situation to resolve from a standard and regulation point of view. So that's something to keep in mind during the next decade, is that there will be changes to standards and regulations, but how these changes are moving forward, then sometimes it can be quite slow, especially with structural wood products, which of course the mechanical safety is one of the most important factors, and nobody wants to sort of bring products to the market that are maybe environmentally friendly but aren't safe to use in practice. Now about the adhesives, so how are they developing? Well, one of the things I mentioned was the life cycle analysis, and that's looking at the carbon footprint of the product and also some other chemical footprints of the product. And one of the main things there is that actually over 80% of the carbon footprint of a product comes from the raw materials. So if we want to make a big difference to the carbon footprint of the adhesives inside CLT, then we need to look at new raw materials. And currently, many different types of adhesives are based on synthetic or mineral oil products. And what we actually want to do is to make them based is to introduce bio-based products and also bio-based synthetic products, and use recycled materials where we can. And these three factors will reduce the carbon footprint of the adhesive quite a lot. So that's why they're very important. One highlight, which I think everyone is very interested in, and we've been researching for some time now, is that we can actually use components from wood to bond wood. And that makes it a very elegant sort of circle where we're using the same raw materials to bond wood as are in wood, and we can look at the material as more of the same material, so that adhesive isn't so different than the wood. So that's very interesting. Another project that we've been involved in is that actually I mentioned that carbon dioxide is produced from the reaction of the adhesive with moisture. Of course, that also means that carbon dioxide is part of the structure of the adhesive. And so we can actually capture carbon dioxide from the air and turn it into the polyols that are needed to produce the adhesive. That will take a bit of work. Still, it's not quite ready, but it's a very exciting vision for the future where we can combine the air and wood, for example, to create the next generation of very low carbon footprint adhesives for CLT. Those are my topics for today. Thank you very much.
Welcome to the live discussion. I'm now joined with my friends rather than flying solo. So to start it off, I think we can review the poll results and we'll go from there. So the first question was, do you have a business related to CLT? And a majority of people actually said, yes, I already have. And sorry, the majority mostly said no plans, but do you have any comments, panelists, for this question?
Yeah, it's quite interesting to see that so many are already involved with CLT. And of course, it is good to see that there are also some plans for the future.
Yes, I think it only tells that we are having a good topic for today's webinar, that people are interested, and this is a really industry that will develop.
Yeah, and I hope some of the percentages that have no plans at the moment, and maybe after this webinar they will have some plans. So.
Yeah, hopefully so.
All right, we'll move to the second one, and it asks, what do you see as the most important property for adhesives of the future? And we'll ask our glue guy, Christopher Mills. And of course, the winner is being green and sustainable. And an honorable mention would be efficiency. And I guess price isn't as important as we would have guessed. What do you think?
Yeah, I'm really happy to see the results of the poll, and I think that reflects the product itself as CLT is aimed at the sustainable market, and it's very important that we develop the adhesives in the future also to make the whole product more sustainable.
All right, let's move to the third. What opportunities do you see in the use of CLT for construction? And unsurprisingly, it would be mostly for schools or public buildings and high-rise buildings, as well as homes or detached houses. Not many other people saw, I guess, visions for other uses so far, or at least offered one. Any comments?
It seems so that these high-rise buildings, they are getting all the time higher and higher, and it is also nice to see.
Yeah, and I think the schools and public buildings is an interesting trend as well. So a lot of time is spent at school for children, and so the environment that the school provides is important. And we all know that wood is a very inspiring material. So I think more wooden schools means more inspired students. What do you think, Juha?
Yeah, and I think as we know that young people are our future, and it's very good that we can keep our children in a very healthy buildings like CLT houses. So I think this is a good trend.
Yeah. Do we have Janne on the line to comment as well?
Here, can you hear me?
Yes.
Hello. Greetings from Oulu, the world's northernmost school of architecture. Nice to be here.
Thank you, Janne. So for the next question, what's your desired production capacity? I know this is a rather technical question that many people weren't probably prepared to respond to today, as you can see, with no plans at the moment. Anything here, or do we move on to the next one?
I could say so that it is also quite interesting to see that not all the plans are for really high capacity, so that it will be also maybe a little bit more simple lines and at least less investments. So something to start with. So that sounds also quite good and interesting.
All right, and then People from the audience responded, where do you see the biggest challenge in production? And I guess we'll see the results in 1 second. The last question.
Yeah, I think this has some connection to this. What has happened this year, as we have faced that the price of the wood has been exceptional level this year, and I understand it has causing worries to many people working in this industry. But I believe in the long term it will be more stable, no problems.
Now we see that regulations took the cake for the biggest potential challenge in the future. So it'd be interesting to see how that plays out in different countries.
Yeah, I think regulations are affecting everyone in the value chain, but in a slightly different way. So it's not surprising to see it as a big answer in this poll.
All right, so I think it's now a reasonable time to move over from questions from the audience. And we'll start off with kind of a softball question. And the first one is from Vasco. What are the shelf lives for polyurethane?
Yeah, that's a good question. I'll answer this one. It depends a bit on the product. So different products have different formulations, and different formulations have different stabilities. But the range is from 3 to 4 months to 12 months, even for the most sort of stable formulations. And of course, that's something we're working on constantly to improve with all of our products.
Yeah, but I think this is not typically very big issue, because the CLT factories, they use quite a lot of adhesive, and the product is typically packed on 1,000 kilo packets, and it means that it will be used in a couple of days. So normally there's no need to think about if the product is not usable anymore or not.
Yeah, I guess if the transport takes a long time, or there's some other reasons, then there could be a need for the long shelf life. And actually, one of the advantages of polyurethane, which wasn't mentioned in my video, is that because it's not water-based, it's a different chemistry, then it actually doesn't matter if it freezes, and that can be sort of easier to transport long distances. For example, Siberia, we all know how freezing it is in the winter. Then it makes it a simpler adhesive to transport to long distances.
Yes, that's right.
So follow up from the original question there. He says, question for the glue guys. Do you have a polyurethane glue that have shelf lives for 9 months and a curing time less than 5 hours at 20 C?
Yeah, we definitely do.
All right, now I'll move back up to the top. A more technical question here is, roughly, what would be the cost for building a CLT factory in CEE, and what would be approximately the target output price for the CLT panels per square meter, 19 millimeter thick, spruce 3 layers?
If we think of the production line, okay, there was not mentioned what is the capacity. So there are so many different features in the line, so that it is quite difficult to say. But if we say some rough number, from including machines, maybe 6-7 millions up to 20 million or something like that. So I think we are somewhere there in the price wise.
And I guess that target output price is dependent on the raw materials, as Juha mentioned earlier. Then the prices have been quite crazy over the past year for wood as well, and that of course affects the CLT industry a lot, because there's a lot of wood in the CLT panel. So of course the raw material costs are a big variable. So we have to check at different raw material costs what the final cost would be.
Yeah, I think typically in that kind of products, the raw material cost covers some 70% of the variable costs, and as this year has been a very exceptional year when it comes to wood price, it should mean that the market price of CLT is also this year much higher than in normal conditions. But I have no idea what is the normal time market price.
Yeah, and
for
I think
CLT.
the price is a very important aspect also to what we've discussed in Pinomatic's videos and my video as well about production, because the more effective your production is, the smoother it works, the faster it works, then the cheaper product you're producing. So in that way, it's a very good way to think about how to design a factory. Is maybe the initial investment is bigger, but then the output is actually cheaper if you have a very efficient factory.
Exactly, and sometimes there are a lot of discussion of different speed in different place of the line. So, but the most important thing is, of course, the output of the line. That is the way to earn money. So.
Yeah, and actually, I was very happy to see that the participant didn't see the adhesive price so big thing, because we know that the typical adhesive cost is something like maybe 15 euro per 1 cubic meter, and at the same time, the wood cost is like at least 300-400 euros per cubic meter. So it's a very, very minor cost compared to total cost.
To switch up the conversation in terms of sustainability, one person asked, what is the role of adhesive in the emissions of a newly built building? I guess in the production or in the use of the building?
Yeah, so when we talk about emissions, then there's a couple of different angles or a couple of different things we're talking about. So one is the emissions from the adhesive itself, and that's in the production phase. And there we need to make sure that all the workers are safe, and then we also sort of test our adhesives to what are the emissions in the production phase. Actually, most adhesives, polyurethane especially, then after the production phase, when the CLT is ready, then the emissions drop very quickly to zero, so far before it gets to the building site or even the finished building. So the actual role of adhesive emissions in the sort of indoor air inside the finished building is practically zero for a product like CLT. So typically the role of paints and furniture is much bigger in the sort of emission load of a new building. I think we all know the new car smell, and that's it's the same thing with a new apartment building, that when you have new furniture and new furnishings, new paint, then there will be some period of time where the emissions are a bit higher in the indoor air. And actually it's been studied quite a bit, and roughly 6 months from the sort of when a new building is built, then the emissions fade to the sort of long-term level. But there is a sort of load from paints and furniture, but fortunately from adhesive and CLT, then there's not a load in the new buildings.
So related to that, another person asked, indoor air is a growing concern in new buildings. Can you explain a bit more about the M1 classification, what it means, and is it recognized across Europe?
Yeah, the M1 classification is a system that's used mainly in the Nordics, and it's actually a Finnish system from RTS, the Rakennustietosäätiö. And what it is it's measuring the emission profile of the sort of dried construction product or the dried adhesive. And it's actually a lot stricter test than a finished product of CLT, because it's measured only the adhesive sort of drying after 1 month and seeing what emissions are coming out. And it measures all the VOCs, so the volatile organic content, and also the formaldehyde levels. And actually one strange thing about the M1, or one fun thing, is that they actually do a smell test. So they have a panel of experts who are smelling the product, and they give a sort of evaluation from 0 to 10 on how bad it smells. And that can actually fail or pass your M1 test if your product smells bad. But it's an important system, and there's many systems across Europe and across the globe, as I showed in my picture in the presentation, and there are slight differences between them. Some look more about formaldehyde than other VOCs. Some are more focused on total VOCs, but the main content of M1 is the same as all the different classifications to make sure that products are safe for the end users.
Yeah, and even M1 is a Finnish origin certificate. We can meet that requirement also from Europe. For example, we have requests from UK that they require M1 certificate for the adhesives.
Yeah, and we want to promote having sort of global emissions certificates because, of course, it makes our lives easier because we don't have to then do 10 different labels on products. So it's very nice to see that the M1 is gaining momentum in the Baltics and in other places in Scandinavia. And actually the SWAN label, which is maybe more familiar to consumers, then that label is looking at the M1 as a good test for the emissions.
Thank you for your patience, everyone. Some technical issues. So we'll go back to the question that I just asked. Maybe Janne could offer something in this, but how do people view the future of hybrid structures between concrete and CLT? Maybe Janne can't hear us. Anybody here?
Yeah, at least I think that the trend we have seen lately that different materials are combined to one construction site. I think it's only good thing that we utilize the benefits of all different material. When it's worth to use steel, it's okay to use, of course, but when possible to use sustainable material as wood, I think it is very good.
Yeah, agree, because of course there are different kind of buildings. There are different kind of demands from the outdoor use also. So it's good to have this combined.
Yeah.
All right, so we'll move to another one in terms of end of life. One person asked, is it possible to recycle CLT to particle boards? Are adhesives a problem there?
Yeah, very interesting question. And end of life is something that I think 10 or 20 years ago we didn't think much about as a group, but now it's becoming a lot more important. And for CLT, then definitely yes, it's possible to end of life it as particle board. The adhesives don't pose a problem. Actually, similar products are used nowadays to prepare or to produce particle board. So in that sense, it fits well. But I actually think there should be a lot of phases in between. So either we upcycle or we reuse the CLT panel because the panels we are producing today with modern technology with precise lines, then they're so good that they should last hundreds of years. And then if they're not used anymore in a block of flats or something, then they can be used in other uses, maybe recycled in holiday homes or other places. And we're making products that are built to last. So the end of life is a long way away, which doesn't mean that we don't think about it, but just that I think we can also get a very high sort of priced product at the end of life, the CLT panel, not just a particle board.
And to kind of nail it down, would you say that either in terms of glue or wood, does one outlast the other? What would you kind of project the whole life cycle for each one be? Is it simultaneous? Would they kind of meet their end, or is one going to fall apart before the other?
Yeah, very, very interesting. No, they don't suddenly decide to fall apart. It depends on the conditions. So there's certain microbes and actually UV light, so coming from the sun is degrading wood over time, and it depends whether the sort of blue line or the wood is is in different conditions, whether it's in the sunlight, whether it's getting rained upon or so on, which will degrade first. But usually the sort of basic design principle around adhesives, such as the ones used in CLT, is that the adhesive is lasting a lot longer than the wood around it. And that's generally what happens, is that the wood is degrading faster than the adhesive.
Yeah, we have to remember that CLT is still quite young product. Maybe the first CLT was produced 20 years ago. And as we estimate that the construction will last at least 50 years, so maybe our colleagues after 30 years will have to think about how to recycle CLT houses. But of course, it's a good topic to discuss and think about.
Now to kind of discuss other engineered wood products, one person asked, could you please compare CLT, LVL, glulam from the perspective of most efficient usage of timber biomaterial? What applications in the buildings should be made out of CLT and where other engineered wood products could work better?
Yeah, that's a good question, and
I think
Janne,
yeah.
please.
Yeah, hello. Well, I would say that it, of course, depends on where you are using these products. Similar than if we think about where to use concrete or where to use steel and where to use wood, we have a different kind of wooden materials like LVL and CLT, and they are all glulam timber, and they all have different advantages. So I would say that we have to be very careful where to use which product.
Yeah, and I think one of the features of CLT is the finished surface for indoor use, and LVL panels usually aren't used, for example, for indoor walls directly. So that's already one aspect. So where we want to see visible surfaces of wood, then CLT is providing a very good surface.
And while we have Yanni on the line, I think maybe one of your students asked this question, but do we have a specific training on CLT for our future architects, for example, on design and efficient use of CLT panels?
Sorry, can you ask again?
Sure. It's kind of a two-parter. So do we have a
Yeah.
specific training on CLT for our future architects?
Yeah, well, we have actually started complementary education for especially of mass timber products. That includes CLT and other mass timber products as well. The situation is, of course, such that because these are relatively new products, so they are developing all the time, and also the legislation is developing around them. So that's especially kind of a thing that needs to be followed, the development of these products, and therefore we need this continuing education programs also.
Okay, good. And everybody's favorite topic, we're going back to glue. What is the average wear of polyurethane glue per cubic meter of CLT?
Yeah, so I think it was mentioned at some point, but per cubic meter of CLT, then it depends on the thickness of the layers. So there's no sort of simple answers to the question, but generally, as said, the sort of 150 grams per square meter, and then depending on the thickness of the pieces, then you maybe have 30 layers in a cube, so that makes 4.5 kilos of adhesive per cube.
And in terms of similarities and differences, can you maybe talk about comparisons between adhesives for CLT production and LVL production?
Yeah, they're completely different currently, or at least the main products used to produce LVL are phenolic resins. So they're a type of adhesive that cross-links using formaldehyde. And then the main idea there is that LVL is a very thin layer, so it's 3 millimeters thick, usually the veneer, and it's using a water-based phenolic resin to sort of impregnate, in a way, the thin veneer and then to become bonded into an LVL panel. And actually, at that point, the variety grows because there's a certain heat needed. So you need a high temperature to bond with phenolic resins, and high temperature and thickness of panel are sort of problems for each other. So you don't get the heat transferring through the panels. So the maximum sort of easy LVL thickness is 60 millimeters, but then you want a panel that's much thicker. And so then you can use another type of adhesive, polyurethane or EPI or MUF adhesives, to bond the LVL panels together into multiples. And that way you can make an LVL panel, which is the thickness is needed.
And kind of related to that topic, one person's interested in the edge gluing and the cracking. So how about cracking of the surface when you have the edge glued panel on the surface? With non-edge glued panel has straight stripes. Edge glued have cross cracks that are less attractive. Have you got any comparison? Is that clear enough?
Yeah, I think that's a good question, and I think it's very dependent on the whole CLT panel. So there's different thicknesses of layers, different moisture contents of the wood, and the cracking behavior is dependent partly on what conditions the panel is in. So I don't think there's as simple answer as maybe the question was, that with edge glued panels you get more cracking, and with non-edge glued you get less, but it's sort of dependent on the conditions and the whole panel structure, how the wood cracks. And that's something that personally I think is one of the interesting things about CLT, is that it's wood, it's natural for wood to crack. So the sort of, it's a beautiful surface, even if it has a few cracks in a different direction to the sort of wood.
Now, you mentioned that CLT is kind of in its infancy, that we have some years until it kind of matures to see the end of life. But one of these people asked, how do you see the recycling reuse process of CLT probably happening or is happening? Could you speak upon that as a group?
You mean the side streams of the production?
I guess
Good.
here they're specifically asking recycling or reusing. Is there a process in place? Is there one planned? Is it just hasn't occurred yet?
So you mean, are there currently any?
Recycling processes.
Yeah, I haven't heard any of such recycling processes.
What? Oh,
Yeah.
Janne, he's got his hand.
Of course, if we think about, generally speaking, the recycling of building materials, so the best thing would be to learn how to use them in similar products as they are. Like, for example, the less we need to process them when recycling, the better it is. And of course, since CLT is such a new product, so we don't have that kind of experience yet. So, but that is one big issue, I would say, that we need to think about and learn about, that how we plan also the phase when the building is, let's say, deconstructed or recycled or transferred to something else. And that is not only with the CLT but also with other building materials, a big question in the future.
Yeah, maybe one point of view for this discussion is that I think all CLT producers are thinking about how to utilize those parts of the product that are cut off during the process, like windows and doors. And what I have seen, that there is a lot of ideas how to utilize those secondary pieces, and there has been maybe we can speak about the secondary constructions like dog houses or barbecue cabins or tables or chairs, and that kind of products have been made of those windows cut off original CLT panel.
Yeah, I think it's because there are sort of two trends at the same time. So the trend is to have big windows and big sort of glass areas in buildings. Then it's working nicely with CLT because you have a blank slate that you can cut out the doors and cut out the windows, but then you have a problem of what to do with the doors and the windows, and the wooden material is bonded already, and it's sort of increased in value. So of course you need to find a way to sort of have a high value product also from the sort of offcuts, and maybe that's one of the challenges for Pinomatic in the future, is to build the line so that the offcuts are sort of utilized immediately in the same process, so there's not the need to store them separately or to ship them to another player in the industry, and maybe the companies can directly produce many products. So they have the panels that they're sending to building sites, but also the offcuts that they're using for something else.
Yeah, I totally agree, and I know that there are some new ideas already what could be the final product for those PCs, and I would say in maybe 1 or 2 years there will be still some more, so that is also interesting to follow what kind of innovation there will be.
Yeah, and I think the most sustainable solution, of course, is to not press the windows. When you assemble the CLT panel, and before pressing, you already have the hole in the panel before gluing it together. So you don't even have to saw it off. You just trim it.
Yeah, that would be very interesting to see.
Yeah, but that is a big challenge. There are some solutions, but maybe we'll see something new.
Yeah, and I'm interested to hear if Janne, if architects think about these things when they're designing a house from CLT to sort of optimize the material usage in the sort of final building.
Yeah, definitely. I was just thinking about that. With CLT, of course, it would be best if you don't need to make any holes to the boards, and therefore you have to think about the whole architecture and whole way how to use the panels in a such way that you make windows, for example, in between panels, and that creates certain kind of architecture. We call it actually, this kind of thinking is called tectonics, which means that every material has a unique and own kind of tectonics, and definitely CLT, it's quite close to what we how we use concrete, prefabricated concrete elements, but of course the end result is totally different.
Now, do you see CLT being here to stay, or is it going to be left in the proverbial like sawdust, meaning that it's just a hot topic today and that next month, next decade, there's going to be something else in the spotlight?
Yeah, it is really hot topic, as we see that almost in every country there is new factories coming and already on production, but I don't believe it will disappear someday. It will stay, and the reason for this, I believe, is that as we almost every day we hear some news about climate change and how we should make our carbon footprint smaller, and I think this is sustainable solutions that we use wood material which is sustainable material and also supports the local economies in countries. It creates a lot of jobs to people in forestry, in sawmills, in CLT factories, in construction sites, in architects. So I really believe it will not disappear because lot of benefits, both economical and environmental.
Yeah, I also agree, and I think there's a lot of interesting aspects to CLT which will make it sort of be around for a long time. And one of those is that it's not too economically sort of cheap to transport a CLT panel for a very long distance, because there's some mass in the panel and they're large. As mentioned, CLT plant has 60 meters times 3.5 meters. And that actually creates a product which is sort of more sustainable to produce locally. And so there is some sort of there's a need for CLT factories in everywhere where there's woods, so that we can use the wood and turn it into CLT, and that's sort of will create a self-sustaining ecosystem sort of in each local area around the factories. So it will make sense to have buildings of CLT very close to the manufacturing plant. And another point, just to add to your sustainability answer, then if you actually design a building with enough CLT, then you can actually offset the carbon emissions of the whole building life cycle. So you can actually have a carbon negative building, because every sort of kilo of wood that you have in the building is taking carbon dioxide from the atmosphere and locking it into your building for tens or hundreds of years. And if you have enough wood in the structure, then actually the energy taken to heat the building over time, or the electricity and the emissions of living, then you can actually get very close to a situation where your actual building is saving so much CO2 that you're not sort of emitting enough to offset that, and you get a carbon negative building. And that's something that I think will be a trend, at least for a small segment of society who is willing to pay a lot for their building, and to be sure that it will be sort of good for the environment to build with CLT.
Yeah, and I think that we have to remember that even maybe nowadays the CLT is maybe a bit more expensive solution than, for example, concrete. But the industry is very young, and the whole value chain develops. It is still on the development phase, so there will be like more efficient ways how to make CLT. There will be more efficient ways how to handle the logistics and construction phase and so on. So I really believe that the price difference will come closer to concrete in future.
Yeah, and one point which Janne made at the end of his video, which was that innovations don't stop with CLT, but they keep going. And so what will CLT products look like in 10 years or 20 years or 50 years? I think it's quite certain that they won't look exactly the same as they look today, but the sort of basic structure and the basic product is becoming so widely used that there will also be a lot of innovation about how to use CLT, how to use it for balconies, how to use it for different parts of the building, and that will continue for a long time.
Yeah, it's a very big question if we think about historically building, how we have built and what kind of architecture we have made. So actually, a little bit more than 100 years ago, we still had quite a few techniques and materials where to build from. And then after the industrialization of the building industry, so there has been a huge amount of different kind of materials and different kind of techniques. So it would be quite, I would say, strange to think about that CLT will stay as it is for the becoming decades, since it's such a new product anyway. But I think that in some form, wood and ways to connect wooden pieces together is definitely some kind of technique that will continue in our building vocabulary, so to say, because it has been there anyway for thousands of years.
How have you and Pinomatic seen the development of CLT and the needs for new manufacturing processes and new innovations around the product?
Yeah, for sure, there are all the times some development and small and some bigger things to do, and that is also one interesting question to ask from glue supplier. What do you think that is needed from machine supplier from glue point of view in the future? What are the important things?
Yeah, that's a good question, and I think if we look at the sort of customers and the people who want to produce CLT, and what they are asking is they are asking for quite flexible things. So that's one answer, that they're looking for different kinds of solutions. They want to, of course, serve different kinds of customers. So they want to be able to flexibly produce different thicknesses or different sort of sizes of panels. And that, of course, creates a challenge for the mechanization and as well as a challenge for the adhesives to be flexible in different situations.
Yeah, I agree. And of course, it is really so that the situation, what kind of product you want to produce now, and then you need to estimate what could that be after 5 years. So the flexibility of the production line is key word.
Yeah,
Right.
and another point is one that we're reaching gradually as the product has matured is the speed of the lines and how to get the output desired. And there's a lot of factors there to do with the adhesive speed, which makes it more difficult when it's fast to if you have a small mistake in the line, then that sort of it's making a bigger problem. But also from the mechanization to get the pieces. So if you have a fast adhesive and a slow line, then you have a slow line.
Mm.
So we need to work together hand in hand to sort of take it to the next level and how we can get a large enough output because the demand is huge for CLT. Even as Juha mentioned, the price is quite high compared to cement, and there's still a lot of demand in Central Europe and in Sweden, and I think soon in the UK and Finland, and also globally in America, South America, Australia, Japan, everywhere. There's a big boom.
Yeah, and maybe one request for Pinomatic could be that as we were discussing about this edge bonding and the role of the edge bonding for cracking, and I believe that there's two like clear way of thinking. One, some of the people are thinking that the edge bonding is needed, and some of the people think that it's not needed. But maybe you should make a flexible plan that it is possible to produce both way, with edge bonding and without edge bonding.
Yeah, that is also of course true, and it is in some phase it can be better to use not edge glued and somewhere better to use. So again, this flexibility of the line is the key word.
So the last question has this kind of comparison between concrete and CLT again. And as it's kind of common knowledge in our industry that concrete, if it were a country, would be the third most polluting after the United States and China, responsible for 8% of global emissions, and then iron and steel, another 5%. Is there any data available today on the emissions of CLT, or like you mentioned that it was kind of could be carbon negative?
Yeah, I think we need more data because, of course, the wood is carbon negative, and the tree in the forest. As I liked how Janne started with the forest and the link to the forest. Then there everything is fine and good, and the carbon dioxide is trapped by the tree. But then every phase after that, then of course we're using energy and we're using transportation and we're using production machinery and we're using adhesives and we're transporting the finished product to the building site and we don't have the information over the whole value chain yet, but that's coming very fast, and that's something we're working on also from our part with our LCAs. So the life cycle analysis is to calculate all the parts that are in our product, and then if every piece of the value chain does that, then we can have a ready answer for that question.
And sorry, I wasn't listening so closely, but another person asked, does CLT have its own data in LCA databases? Was that already answered?
Yeah, definitely it does. As none of us are CLT producers around this table, I don't think we know the exact value by heart, and it depends on the factory and the other things. But that's becoming a requirement for construction products, that there is data.
And I guess from a more business-led and marketing perspective, there's kind of these misconceptions around CLT that it's this less noble raw material. How do you think going forward that people can see it in a different way? For example, people think that wood is more flammable. Could you speak about maybe the fireproofing properties related to CLT?
Yeah, definitely. And I think part of my answer is the same as Janne said in his presentation. We've been using wood for thousands of years, and it hasn't suddenly become flammable. So we all know that we can use it to eat hot sausages over a fire in the woods, hopefully. But I think that's also something that's often misunderstood. For example, if you I'll now comment on glulam beams compared to steel structures, then actually a glulam beam is a lot safer in a fire situation than a steel structure, because once the steel reaches a certain temperature, it melts totally. But wood burns slowly with a sort of charring rate, and that's something that CLT producers are calculating into their product, is the charring rate of the wood. And sort of whenever you make a building, of course, you have to think about fire safety and whether there's enough thickness of wood to make it fire safe, the whole building. And in different countries, there's different legislation, and one of the solutions is to use sprinkler systems. That's maybe a expensive solution, but it still gives the sort of peace of mind that the high-rise buildings with wood with sprinkler systems are definitely as safe as any concrete high-rises.
So the way I see it, CLT is kind of a sandwich with two pieces of bread, maybe a spread in the middle. But somebody here points out, is there an idea for innovation in terms of CLT solutions by gluing other types of materials between wood layers, such as improving thermal conductivity or fire safety? Is there room for ham, lettuce, and tomato?
I would say definitely there's room for different kind of solutions and novel products. I'm not sure what is the thing that each of us wants to put between, but the future will show.
Yeah, I think it's definitely a space for innovation for all of us, and I think that's one of the interesting things about a new construction product is how it forms the basis for a lot more new innovations. And there's a lot of properties with CLT that are sort of interesting from that perspective, that you can sort of cut into it, you can make holes, you can have different sort of surface materials glued onto the surface, and that gives it's a sort of good platform for a lot of different things.
The questions seem to be slowing down, and I know that we've kind of focused on glue. Is there anything that Pinomatic might want to add about machinery that they thought that was overlooked or they could add now?
I could say so that when some customer have some ideas to start producing CLT, so it is a really interesting case, and I would say that take some time, go through what are the target for the future, what do you want to produce, how much, what are the limitation, and then when you are thinking the production line, like I said earlier, so think what the request can be after 2-3 years, and maybe after 10 years. You need to estimate something, so be flexible and that produce CLT.
Anything more to add?
Yeah, we've been discussing, of course, during this webinar, also off camera, and one of the things from one of our discussions is how big your factory is. So that is exactly the point. You need to think 10 years ahead. So you need to have room to grow, because as we all hope that your factory will be a success and there will be a lot of demand for the product, then you need to have space to innovate and to also to add to the production line, so you can increase your output along with the demand. So that's something to think about right from the start, is how many square meters of floor space you have to use.
Yeah, exactly, and it is possible to make the investments in steps and think of those steps. What can you do? What can you take in the future? So I totally agree.
We have two questions that saved the day now. So The first is, one of the ideas of sustainability is prefabrication. How do you see CLT in relation to volumetric modules for CLT? Should I read it one more time?
Yeah, I think
Maybe Janne.
both Janne and I have answers.
Yeah, please read one more time.
One of the ideas of sustainability is prefabrication. How do you see CLT in relation to volumetric modules form CLT?
Yeah, of course, that's one of the biggest advantages of CLT is that you can use it in volumetric modules because even if you build half of a apartment out of it in a factory, so it doesn't become so heavy that you wouldn't be able to transport it into construction site. And that is the most biggest advantage when comparing, for example, to concrete and steel. So I see a really big potential with CLT in that kind of way to build.
Yeah, and just in general, prefabrication and CLT are a very good fit because one of the things mentioned is that the CLT panel is, in a way, it doesn't matter which part of it you take, the properties are the same. So I think we all want a sustainable and sort of prefabricated building, but we all also want individual sort of design and individual architecture into our houses, into our blocks of flats, and so on. So with CLT, you can sort of take the same product into the prefabrication process, sort of, so you can input the same panel, and you can produce very different buildings from the same panel, and so you can sort of cut different shapes and so on, and the basic sort of properties of the panel aren't dependent on having the whole 16 times 3.5 meters there in your product, and that's actually one of the sort of interesting things about CLT compared to, for example, concrete or other structures for prefabrication, which generally have sort of strengthened sections and then sort of less strong sections inside the element. Then with CLT you have a sort of blank canvas that you can also sort of customize your prefabricated product. And I think that's one of the areas where we'll see innovation in the next 5 years. I think it's coming very fast now that you have CLT as a base for your module or for your prefabricated element, and then you can serve different customers from the same sort of raw material.
For the Pinomatic crew, are there any CLT factories where a Pinomatic CLT press would be?
At the moment, no. I would say that the designing work is ready for Pinomatic press, and it will be also in the production in the future.
And for the glue, what fire capacity does it have?
Yeah, so that's a specific question. So I guess the fire capacity is dependent on the amount of glue in the bond line and the properties of the glue. So actually with wood adhesives, we're not at the point yet that we're measuring the fire capacity of the adhesive, but there's a lot of studies ongoing, and I think that sector will get a lot more precise in the next few years.
And going back to prefabrication, would you say that does it require more specialized crews to install the cross-laminated timber? Was that another cost factor that needs to be weighed in?
Well, I think that it's good if you have a personnel who is experienced to install and to build up constructions. So in my opinion, yes, but I don't see that as a problem. But of course, you have to understand the difference of the material of CLT and the concrete. It's not the same, for example, what comes to moisture and how it affects on the material itself.
Any final thoughts, Jani?
Well, it's been interesting to follow the discussion and presentations because I think that I've learned a lot also out of the glue and the processing products. So I would like to thank everyone who's been part of this.
And thank you for being with us today. Anything else? Anybody want to shoot a last minute question? We have about 5 minutes to go.
Yeah, maybe we can ask the audience questions. So have you enjoyed the presentations and the discussion today? Maybe if they answer in the chat, you can see. And please answer the feedback form that, as is normal nowadays, then of course we want to know what you thought. That will be coming after the webinar.
Yeah.
Good. It seems like the thank yous are coming in, so we did okay.
Maybe we can then finish.
Yes, and people are just asking about the video material, and I understand that it will be up for the next 30 days as long as you use your webinar sign-in. So again, share with your friends and family or use for your reference, something light and easy for the holiday season.
Something to keep the kids occupied on Christmas Eve.
Definitely. Good. I think that's all for today. Thank you, panelists, as well as anybody that attended in the audience virtually. We appreciate your interest, and we look forward to hosting something similar again.
Thank you.
Thank
Thomas.
you.
Thank you.
Thank you very much.
Thank you very much.